If you haven't done so yet, make sure you pause the video first and try to solve the question on your own before listening on. What we're going to do is draw a free body diagram that shows the forces that are acting at this point right here in the picture, where all three of the ropes are connected to each other. And that point is represented in the center of this Y and X axis. Now, perhaps the most obvious force is the weight of the cat burglar pulling down on that point. So we come over here and we draw a force that's pointing straight down, and we can label that force as being W, which will stand for the weight of the cat burglar. We then have this force that is projecting off and to the right here. We can draw that in here, and in order to support the weight of the cat burglar, that force would have to be pointing upward. And furthermore, we're going to be calling this force a tension force, and we can label that T2. We have another tension force that's pulling up and to the left, and so we can show that in the diagram as well. And that tension force can be labeled as T1. And perhaps for the sake of consistency, we can actually label the weight of the cat burglar as being T3. That way all the forces are marked in terms of these tensions. The next thing we want to do is add some angles to our free body diagram. Now, we were told, if we drew a line straight down here, that this angle is 60 degrees. And we'll notice that we have formed a nice right triangle, and that's because we have a 90-degree angle right here. Since the sum of the angles of a triangle is 180, that means that this angle right here would have to be 30 degrees. And that way 60 plus 30 plus the 90 would make 180. Also, if we look back at the diagram, we were told that this angle here is 60 degrees. And if we look carefully, we can see what might be described as a letter Z pattern. And we've learned in geometry that when we have two parallel lines, which would be the top and bottom portion of this letter Z, when we have two parallel lines cut by a third line, that means these so-called alternate interior angles are equal. So, in other words, this is also 60 degrees. The next thing that we want to do is break our forces into their X and Y components, and we're going to be organizing those components into the following table. In this table along the top, we have the X and Y components, and then we have the three forces along the side. Let's begin with the force that's marked T1. And what we're going to do, again, is to draw in the X and Y components. We'll notice that the X component would be drawn in this fashion here, and the Y component would be drawn in this fashion in order to form a nice right triangle. And we have to be careful how we point the arrowheads of these components. The X component would be pointing to the left, and the Y component is pointing up. And the reason for that is because the original tension force is pointing to the left and upward, and therefore the components have to point to the left and upward. Now, this component that we're calling the X component is adjacent to the 30-degree angle. And anytime we're trying to break components and we have an adjacent component, that will be labeled as the force times the cosine of that angle. And again, we know it's cosine because this is adjacent, and the cosine function involves the adjacent part of the right triangle. This component, the Y component, is opposite to the 30-degree angle. And so we're going to be using the sine, since the sine involves the opposite side of a right triangle. So those would be the X and Y components. Notice the X component is pointing to the left, and that means that it will have a negative value. So we can come over here and fill in T1 cosine of 30, but we want to make sure we put a negative sign on it. T1 sine 30 is pointing straight up in the positive Y direction, so that will stay positive, T1 sine of 30. We can next move on to T2, whose X component points to the right, and whose Y component points straight up. And once again, the X component is adjacent to this 60-degree angle, so we're going to be using the cosine. So that's going to end up being T2 times the cosine of 60. The Y component is opposite to the 60-degree angle, so that will be T2 times the sine of 60. They're going to be both positive because the X points in the positive X direction and the Y points upward in the positive Y direction. So we'll end up here with T2 cos 60 and then T2 sine of 60. Luckily, the third tension force, T3, is easier because it's pointing exclusively in the y direction, and therefore its x component will be 0, and its y component will be negative T3. Now, before we move on, we want to fill in the values for T1 as well as T2, so we'll go ahead and do that right now. We could then actually pick up our calculators, making sure we are in degree mode, since the angles are in degrees, and type all 4 of these expressions in to simplify them into actual numerical values. And when we do that, we should get the following 4 values for the x and y components of T1 and T2. And then to figure out T3, which is the ultimate goal of this problem, because remember T3 was equal to the weight of the Cat Burglar, what we can do is actually take the sum of these forces. And we're really only going to have to do this in the y direction in order to find T3. So we're going to be summing these 3 forces. And when we do that, we would just simply do 200 plus 600 plus the negative T3. So that'll actually be minus T3. And since the Cat Burglar is not moving, that means the sum of the forces must equal 0. That's basically an aspect of Newton's second law. We can add T3 over to the right-hand side so that we can see that T3 is simply the sum of 200 and 600. So indeed, T3 is going to be 800 newtons. This turns out to be the weight of the Cat Burglar.